Welcome to Jimbo's Garage.
Good afternoon, everyone, and welcome back to Jimbo's Garage. Well, today we're going to be doing a machining project. Now, that's something that I long for here in the shop. I primarily do welding here, and anytime I get an opportunity to do a machining project, well, I jump on it. And not to mention, this is going to give me a good opportunity to work with the Kent 1340 lathe and, of course, the KBC mill. This is what we're going to be attempting to make. Now, this is looks like an aluminum 2-inch coupling. It's designed to go inside this tubing right here and join the other piece of tubing together. The customer needs one more of these. This manufacturer of this product says that these aren't available and that he needs this part like yesterday. So let me bring you in, show you a little bit more about what we're going to be doing. Today's video is sponsored by King Metals. They've got all your fabrication needs in one location. From hinges to hardware, balusters to metal decor, brass to aluminum, and a whole lot more. You name it, they've got it. Check them out today at kingmetals.com. Now let's get back to today's video. All right, so here's a closer look at the part we're going to be making right here. It's like I said, it's like a coupling that actually slides in here, and then the adjoining piece of tubing actually slides over the top here. And what it has is it's got a collar right in the very center, and that collar, that's how this thing slides in and stops right there. And then it has this groove on either side. That's going to be a fun one to try to mill. And then, of course, a drilled and tapped hole on either side here. How this thing's designed to work is the coupling slides in here. Then you have a set screw right here that screws in through the top. And when you tighten that set screw, it expands this groove, and that's what holds the coupling secure into the tubing right here. All right, so I've got a piece of 2-inch aluminum round bar stock right here. This is what we're going to be starting with. This is about this center collar part right here is about 5 thousandths smaller than 2-inch, and this is about 2 or 3/10 larger than 2-inch. So we've got enough to skin the top of this down smooth, and then that's where will be our starting point for the center part of this collar. Then we'll machine it down. So sounds like a fun project. Let's get started. All right, so the first thing I want to do is I've got the bar stock right here, and I want to cut it to the approximate length right here, which is about 4 inches, a little bit stronger than 4. Now, clamping this thing in the evolution right here could probably get a little bit dangerous with the round bar stock. What's pretty cool is evolution also includes this this little jig right here for, you know, holding more securely round stock in here. You just slip this right in right there like that, and then what we'll do, we'll be able to, you know, secure this a little bit more secure than what it normally would be. I'm just going to get the pretty in it. Okay, I'm right where I want to be right there. All right, I'm just going to crank this thing down. One thing I want to point out too is there are blades for cutting aluminum. I have a steel cutting blade on here right now, but if you could do a lot of aluminum cutting, it'd be advisable to put aluminum blade on here, because what happens is the aluminum has a tendency to gum up the steel cutting blade. So I'm going to go nice and slow through here and back it off so it doesn't have a chance to heat up and gum up on there. But if you cut a lot of aluminum, definitely get an aluminum cutting blade. All right, let's do it. Yeah, so these Champion cutting tools have aluminum cutting blades. I happen to have one, but I didn't want to take the time to change over, so I just stayed with it and took my time with this. And for this small piece, it'll be just fine. All right, there's our piece. Let's get over to the lathe. All right, so I'm over here at the Kent 1340, and I'm checking up the piece right here. And the first thing I want to do is face the end. Now, I've never done anything like this, okay? I've done a little bit of machining, so I'm a little familiar with some things. And so I'm just kind of, I'm a novice at this, so I'm just learning as I go right here. So once I got the end faced off, I knew I just had a couple thousandths to go to clean up the outside edge right there. And I didn't want to overshoot the collar thickness. I knew I had a little bit of room, but I just wasn't certain, so I just kept checking it as I was going there. I didn't want to overshoot it, that's for sure. You know, the tolerances on this have to be pretty tight. They got to fit tight inside that tube, and this collar needs to be flush to the outside. So there's not a lot of room, so I was just trying to hit my mark. So I got one more pass right here, and I think I'll be there. All right, so now that I've got that, I've marked the edge of the collar right there, and I'm going to go ahead and turn this down right to it. And once I got there, I've got an indicator set up right there, and I've set my indicator so I'll be able to stop right on that mark right there. So now it's time to turn this side down, and once again, I'm just taking some cuts. I'm taking it nice and slow. I don't really want to overshoot it, so I'm taking my time going through here. You know, I've done several projects, small projects on the lathe, and you know, I've really enjoyed it. This is a lot of fun for me. I'm primarily a welder, but you know, I do love to do machining work, and I'm learning every day. All right, so I've got this side down, and I'm just going to put a chamfer on the outside edge right here, and then I'm going to slide down and just knock the edge off of that collar, and that's all I really want to do. And that side is done. I'm just going to flip it around and take care of the other side. You can see I cut it a little bit strong right there, so it's about 1/4 or 3/8 strong. So I'm just going to take some cuts right here and just kind of get it down to the right size. Amateur move here. You can see the chips starting to build, and I was so entailed in trying to get the right dimension. I didn't want to overshoot that. I wasn't paying attention to the chip buildup here. And you know, I should have taken those chips and shoved them off the table right there, but I wasn't even paying attention to that. I just was so concerned about hitting my mark that I didn't even notice. All right, I think this might be the final cut right here. Yep, I'm done. All right, chamfer this side, knock the edge off the collar. Chips are getting in the way, obviously. All right, there it is. Got that part of it done. All right, so we're up to KBC now. Here is our part. I just finished it up on the lathe. It's looking pretty good so far. This is a comparison to the part that we're trying to match right here. So far, so good. It's looking pretty good. So now it's time to do the milling function in this, which would be cutting a slot on either side. Oh, right now I want to I'll show you guys a new addition to the mill right here. This is the Vertex Super Spacer. Now this is something that I've wanted for a long time, and as you guys know, these things are fairly expensive, and I've just never been able to want to pull the trigger on it until I finally just couldn't stand it anymore, and I did it. You know, fortunate for me, there's a KBC Tools very close to me, a couple miles away, and I decided to go ahead and make the move. The difference between the Super Spacer and the Simple Spacer is the Super Spacer's got a little bit more functions to it. You're able to actually set it on the bottom right here, and then it becomes a rotary table. And then you can also remove the chuck, and it has this fixture plate right here that can be put on here and used as a rotary table as well. So it's got a couple of the functions. I'm sure that there'll be years of practice with this, but for today's function, what we're going to be doing is just chucking it up in the chuck right here, and then we're going to be milling the slot in here. So let's go ahead and get that done right here. I'm just going to run it right up to the shoulder here on the chuck. Rotate this around here. There's a little lever on the back side right here that allows you to index this thing every 15 degrees, 360 degrees. All right. Got everything locked into place. Let's bring this over, and what I'm using right here, I don't know if you can see this. Yeah, let me move the camera here a little bit for you. So what this slot is it's roughly 17 or 7/16, and I don't have a 7/16 long mill, and I couldn't get hold of one. KBC didn't have one at the time, and so what I've got is a 3/8 long mill right here in mill, and that's what we're going to use to just bring it right along here. And then to make up for the 7/16, I'll just go ahead and move it 30 thousandths to either side and bring it out to clean up the cut. We'll do the same thing on both sides. Let's go ahead and get started. All right, I'm having to manual feed it because it's, I think I'm in fear that it's going to move a little bit too fast, even on the slowest setting on the power feed. I'm afraid it'll break the tapper. You know, this is almost 2 inches thick material, and I'm just afraid that it's gonna snap it. So I'm just manually feeding it in. Now we're going to be going about 1.5 inches depth of cut in here. It's going to take a little bit of time. I'll just take it nice and easy though. Yeah, I'm telling you, this was quite a learning experience right here. You know, I was so overwhelmed at trying to make this groove cut, and watching those chips pile up right there, and then not thinking about coolant. It just became a problem, and you can just see everything loading up there. Everything was getting hot, and I realized it here right when I had finished this side that I better put some coolant on. It's a big problem. All right, so when I got it done, I just flipped it over. I hooked up the mini cool, and I got some cool mist going with it, and it was like night and day. I'm telling you what, that cut went so smooth, so effortlessly. It worked out really good. You know, keeping it cool is definitely a trick. But one thing that was happening here is a lot of chips and a big mess. So there it is. I cleaned up the one side, and I'm coming back the other side now to get my 7/16 width. And I gotta say, it worked out really good, but oh, there it is. I gotta tell you something. Wow, what a mess. I wasn't expecting that much of a mess. You know, it's not perfect. I did make a mistake, and let me get this cleaned up, and I'll show you what I did right here. It's not going to be a very big deal because this coupling is still going to work, but I'll tell you my mistake and I'll learn from it. So let me get this cleaned up, and I'll show you the complete project here. All right, yet just another mistake. I'm drilling the holes for the tapped holes right here, and I thought it was 1/4 20. and it's actually 5/16, so I'm drilling this number 7 right here, but I'll get it fixed up. You know, just so much going on that I didn't realize what I was doing there. All right, mistake after mistake after mistake. This one right here, I thought it was a 1/4-20. Actually, it's 5/16 tap. So we have a letter, I believe it is a letter F drill bit right here. All right, that taken care of. Now I just want to put a little countersink on here. It's about like that right there. I got these new speed taps. I got these also at KBC Tool. They're pretty cool. There's a set of about 4, 1/4 inch, 5/16, 3/8, and 1/2 inch. They also have metric size. The great thing about these things is this is a 5/8 tap size right here, and it corresponds to the same size socket, 1/2 inch. 1/2 inch socket, 5/16. That's the same size as what the head is on a 5/16 bolt. They're pretty cool. They're designed to go on a impact driver or drill. So we're just going to set this thing in there. Put a little oil on it. This is aluminum cutting oil. We'll put a little bit in here. Put some on the tap. And we'll give it a try. It's the first time I've ever used this, so let's see how it works. Well, speed tap. Wow, that was a speed tap, all right. Let me see if I can find the, all right, this is the set screw, 5/16. Yeah, that works pretty good. Nice tight fit. You can work it with your hand. All right, pretty cool. All right, I'm just gonna flip this around, do the other side, and our part will be complete. Now I'll show you all the mistakes and all the corrections. Okay, so here's our part right here. This is the one we made. This is the one that is replicating this factory part right here. Now, there were some mistakes. I want to talk a little bit about that. When I first cut this one right here, when I first cut the groove in here, or the channel in here, you saw that I didn't use any kind of coolant, and that's just a lack of experience on my part. I'm not a machinist, you know, don't judge please, but I do the best I can, and I'm learning every day. So what happened is I cut this and it started loading up, and the end mill started to slightly get off course right here and started to make a little bit of a rough cut, and that's why you see that that is the way it is. I recognize that, and then on the next side I used the coolant, you can see right here, and it turned out absolutely perfect. It worked really good, and that is definitely a way to go. A nice clean cut. That coolant made a huge difference, so that's something that I learned when we're cutting aluminum like this, or a big piece of metal like this. It's important. I noticed that aluminum gets hot really fast, so it's important to keep it cool. And that that mini cool with the cool mist worked really, really good second time around. I'm not going to remake this part. It's not absolutely perfect, but it's certainly not far off. This is going to serve its purpose, and I can just say that I learned from it, and that was definitely a learning experience. And next time I do one of these, if I have to do one, I'll do a little bit better job. But the idea, here's the factory part right here, and so the idea is this coupling right here is going to fit inside here, and you can see that's a nice tight fit, good close fit. And then the set screw right here screws into this and screws all the way down. And it screws all the way down, and it widens this flare, which tightens it inside of the tube. And then the same thing with the side right here. You just put them together and tighten up the set screws, and then that creates a nice straight solid tight joint. And you can see this is the same diameter right here. That collar is the same diameter as the pipe meshed together to create a nice smooth pipe. So that's the idea. The customer is going to be happy because he could not get a replacement one of these, and able to make this one for him, and he'll be able to use it as soon as he wants to. So anyways, hope you guys enjoyed this. I'll social post up pictures of this. It's a good learning experience. Hope you enjoyed the video. Thanks for watching. See you.
See you next time on Jimbo's Garage.